Hello, hi everyone. Welcome to this stream. I hope you all are having a great time at Global Hack Week, Open Source Week. And hello everyone. I'd love to see where you all are joining from in the comments. And how's this week been for you? If you have joined any other session, hi there. We have Mohit. Hi, welcome. We have Zamarine. Hi there. Hi everyone. Welcome to the stream. And today we are going to have a lot of fun. We'll study about and we'll learn about the infrastructure as code concept, and with the help of the Terraform as a tool. So I'll explain what that is and how we can do everything. So yeah, so let's get started with the session. Let me pull up my screen. I do see some questions regarding the non-global hacking stuff from MLS, like the fellowship. So please redirect those questions directly on our Discord server to the fellowship team, and they will be able to help you out. All right. And yes, we will teach a lot of, and I will explain a lot of concepts as beginner friendly as possible. So yeah, we do need some prerequisites, which I will talk in the slides, but this should be if you follow along the stream, then you should be able to understand the things that I've shown over you. So let's get started. All right, let me pull up my screen. I hope you can see that. So yeah, let's get started. Before we do everything else, let me introduce myself. So I am a coach here at Major League Hacking, and professionally I do DevOps and cloud stuff. So I deal with different clients, and we build different automations, and we deploy different applications to cloud. We take care of the infrastructure. We do a lot of configuration. So anything related to cloud, DevOps, Kubernetes, Docker. So that's the kind of thing that I do. And also Terraform is one of the tools which I use almost daily on my professional life. So yeah, that's it's also very interesting, and I'm happy to share that with you all today. And a fun fact or an interesting fact is that I just went to the Oktoberfest in Munich 2 times this last week. So it was super fun. We had a huge party. It's a annual festival here in Germany, and people from all around the world joining. So it's a really fun time, and I had a lot of fun time over there as well. And also, if you want to connect with me on my socials, then I'm mostly active on my Twitter and Instagram, so you can check that out. And I will be more than happy to connect with you all. Once again, I call this as a DevOps land. So welcome to the DevOps land, and I'm super happy to be here. Yeah, Amrit said that they have a background in Docker, Jenkins, and Azure, which is going to be super helpful since you already know some of the cloud and DevOps concepts. But the session is also applicable to anyone who don't know about those things. So yeah, this is going to be helpful for everyone. Yeah, a very important thing that I want to share you all is to bookmark this specific Notion page, because I have provided and compiled all the important code snippets, not the source code, the actual command that we will type in the terminal. So I have compiled those in this Notion, so that's it's going to be super easy for you all to work with. So please bookmark this session, or I'll just also provide this link in the chat so that it's easy for you. Just give me a moment. Okay. And this should work with you all. Just give me a moment. Yeah. So this is the link, and I really hope that you all follow along this, so that it's easy for you to just copy and paste the commands rather than typing it yourself. And then don't forget to check in. So this event, if you have already registered and checked in, that's fine. But if not, then please check into the event, and I can also show you how that's done. So if you go to the event specific link, then here is the login and register button. So if you have already logged in and registered, so this will be a check-in button, and you just need to check in over there. This will earn you some points, and at the end you can win some swag from the MLS team. Yeah, so that's for the check-in stuff. And the Notion stuff that I just talked about, so it looks like this. And so I have provided all the instructions like second link, the prerequisites that we need, like the AWS account and everything, as well as all the authentication stuff and all the command that we will use. Don't worry, I'll explain what all these commands are in the demo. So for your easiness, you can just copy the command from provided links. Right, these are the command. Give me a moment, my monitor is behaving weirdly. Yeah, so all the commands are in this Notion page. So let me come back to the slides, and then this is going to be the session breakdown. So first we are going to talk about the Terraform and what infrastructure as code tool is, and then we will talk about the different components. Like there are different components with this tool, like providers, resource, so all those things, we'll talk about that. And we will have a hands-on demo actually. So not only we will see about the concepts, we will actually configure Terra with and also we will do is we will set up EC2 and VPC to deploy a sample Node.js application. So that's what we are going to do over here. And then for the hands-on demo, so let's get started with all the concepts. Hi, we have Yes joining in. We also have Avinav. So hi, everyone. Welcome again. Welcome. We're just getting started. So let's try to understand what is IaC and try to understand actually the need for the IaC. All right. So IaC, which stands for infrastructure as code. So the problem is that let's say you want to create a virtual machine or provision any resources in your cloud service provider. So this could be things like in AWS or in Azure or Google Cloud or not, or even other services like Kubernetes. So when you want to configure something in them, so you have to go through a lot of different options. So the most common and the easiest one is to use the graphical user interface, which is to log into their console and then go to the service that you want to use, and then you give in different informations and configure it to launch, right? But the problem with that, so this is a screenshot of the page that you will see when you want to launch an EC2. So you see that it has a lot of options, right? And this is good, but the problem is that it tends to be slow and cumbersome if you want to scale. So let's say you want to deploy not just one EC2 instance, but you want to deploy like hundreds of them, or you want to do it repeatedly. So the one time today you set up an EC2 instance, but tomorrow or after a week you might forget all the stuff. So you have to write it somewhere or make a screen recording so that you get it right every time. And that's really, really slow, cumbersome, and also it's error prone. So even if you don't have a need to scale to, like, let's say 100 instances, repeatability is really, really difficult if you do everything by the ClickOps approach that we call, when you click different stuff and you access everything to the graphical user interface. So that is where the concept of infrastructure as code comes in, because cloud and everything related to cloud was built for automation to make sure that everything, applications or product that we built, the mobile app, the web apps and everything, it's shipped to the end user in a fastest way possible. But if you just follow the ClickOps approach, it has a lot of flaws in it, and it's good for beginners, and it's also good to learn different services, like you get to see the different options and you can browse everything. That's good. And I wouldn't discourage you from using the GUI or the console of the cloud service providers. But the thing is that when you want to do it in scale or when you want to do it in production, this is not always feasible. And you want to make sure that there is one single source of truth, and there is one uh, code which specifies how your infrastructure should look like, how your EC2 instance should be set up, or how your S3, or which is like an object storage thing. So I'll talk about those. It's set up. So that is where the IaC comes into play, because it is a declarative. So it means that just the way you write your code. So you write your code and you push it to your GitHub, and then everyone can share that, and they can collaborate, they can find issues, and they can just work together in a collaborative way. Um, you can manage your infrastructure in a similar way. So instead of going to the cloud consoles and creating everything by yourself, what you do is you write the infrastructure as code definitions file. In this case, it's using Terraform, and whatever you have written in that file, that's going to be your infrastructure. And that Terraform in this case will connect to your cloud service provider, for example AWS or Azure, and it will provision that resource and service for you in the way that you have defined, and it's going to be the same every time. So this way you can track your code, it can be version control like using Git, and you have a consistent workflow across all the environment. So just like your code, you also have the workflow for your infrastructure. So that is the concept of IaC. And we have like different categories of IaC, so it's not just one specific category. In this case, Terraform is mostly used for the provisioning side of things. So if you want, let's say, to deploy a web application to the cloud, you mostly would need virtual machines, and also, let's say, if you have some file storage, you would want the file storage service. You would also, let's say, need virtual private cloud environment, so that to set up your networking stuff, to create firewalls, and to manage the different domains. So you need this different kind of services, right, in cloud, and that is where the Terraform excels, and that is where Terraform is mostly used for. But there are also other type of tools like Ansible, Ceph, and Puppet, and these are mostly used for the configuration side of stuff. So once you have your infrastructure up and ready in the cloud, you might want to configure different things in it, and that is where Ansible and other tools is really good, and not Terraform. We will deploy the Node.js application today, and you will see how we can do that with Terraform as well. But for the actual configuration of the Node.js application inside the virtual machine, Ansible and other tools is actually better. So you have all your service ready with the help of Terraform, and then you can configure step-by-step instructions. You can define how those things should be configured, like how the web server should be configured. Let's say you have a Java application, and how your Spring Boot application might run, and how it connects to the database, and all those things can be configured with other tools. So there are a lot of tools, and what we are going to focus today is Terraform, because it's like the basis, and we first need the infrastructure, right? So we will see how to provision the service first. So there is a concept of like the 3-step in Terraform. So you write your Terraform code, which are the definition files. You plan it, and by planning, you mean Terraform will tell you what exactly the infrastructure will look like before creating it. So it won't directly create all the service in AWS or any other provider that you use by itself. So you can first plan it, and it will tell you if the Terraform code is right, if it can actually do the thing that you have defined in the code, and if everything looks all right. And then finally, you can give it a green signal, and then Terraform actually applies that configuration or that infrastructure code on the actual cloud service provider. So it then provisions all the resources. So it supports tons of and hundreds of providers. So Terraform is like the industry standard right now. And if you go in the DevOps career, or if you see any big projects, then most likely they would have used Terraform for the infrastructure provisioning service. So you can provision Kubernetes resources, you can provision any service in AWS, Azure, Google Cloud, in Heroku, in VMware, and a lot of other stuff. And you can see that, like I told, Terraform is infrastructure as code tool, but you can also write the code for multiple cloud environments. So let's say you want to deploy your applications, or you want to use service of like different cloud service provider, AWS, Azure, then you can write all of them in Terraform file, and it's just one like few commands, and everything is up and running. You don't have to go to the console and do everything manually, and it saves you like hours of time, and it's repeatable, it automated, you can write tests for it. It's managed, it's you, all the developers can exactly see how the resources were provisioned. So if they find some mistakes, or if they find some bugs, then they can easily report that. It's easy to backtrack, it's easy to track everything. So it's super easy. You can manage Kubernetes, network infrastructure, you can do a lot of exciting things. We are actually going to see how to use Terraform with a sample project. So just wait for that. We will have a demo session for that. So I will explain everything, and a good question, Amrit. All right, so that's the use cases for Terraform. So the 3-step that I told earlier, this is the summary of that. So we first write the configuration file. So these are the definition file that we write in Terraform. I will see how to what this is and how this works. So everything that you do in Terraform is managed by something called a Terraform state file. So it keeps track of the current resources that is there in a provider. So let's say you want to provision a virtual machine in AWS cloud, so it will keep a track of how actually the environment looks like in your cloud account, right? So if you have not provisioned VM before, then it will be empty. But if you already have, and if you have configured in a specific way, it will keep track of that. And whenever you make change to your Terraform definition file, the next time you apply it, it will actually compare your desired state. So there is the concept of desired state, which is always what you have written in your Terraform code files. So that's your desired state, and versus what is already there in your cloud account, right? What is already there in your environment, that's the real environment. So it will always compare the desired state, what that the code that you have written versus the actual state. And when you do Terraform plan, it will create a plan on how to achieve to that goal. So your desired state is your goal, and your current state is what is on the real world. And whenever you apply that, Terraform will match that. So Terraform will always try to match the desired state that you have written in your code to the current provider that you have used. So that's the concept of desired state and current state, and you can apply it to any cloud provider, any providers. Terraform supports a lot of them. All right, so now let us look at different components. So first, let us talk about the Terraform provider. So let's see. So provider, it's the fundamental component that Terraform needs to do anything. So it is like the intermediate linking layer between the code that you write, the Terraform code that you write, and the target API. So this might be AWS or Azure in this case. So you need if you want to deploy anything to AWS, then you would need the AWS provider. If you want to deploy anything, if you want to create service in Azure, you would need the Azure provider. So it is like the intermediate linking layer, and it is required in every Terraform project, and you can't do anything without provider. And it is the interlinking medium between your project and the code. So let me quickly give you the example in this case. So if you want to actually connect your Terraform code to AWS, then you need to use the provider. And this is how it looks like. As this is a sample. So you define the provider. You can get this from the documentation. I'll show you the docs as well. And here you define the region where the cloud resources are deployed. So in this case, it's the US East one, which is in North Virginia. So that's the AWS data center. And you give it some tags, like these are just the labels, like who it was created by, the environment, like a dev or a test or a production environment, and the name of application. And you define the Terraform version that you want to use in this project. So you give it a version, and then you can see that under the required providers list, you actually are using the HashiCorp/AWS, which is the official AWS provider, and you just specify the version of the provider that you want. So this is how you write a provider. So let me show you how you actually get this. So if you go to Terraform AWS provider in Google, and this is the provider that you will get. And let me zoom this for you. Yeah, so you can see that it tells you all the things about this provider, and you can see as basic example uses, right? So you can see that if you just copy this paste in your project and you apply it, then it will create here you can see that it will create a virtual private cloud. So it will create a VPC for you. So I'm assuming some prerequisites cloud knowledge, but I'll try to explain what I am doing in the hands-on demo. But for now, just think that this will create like a virtual network in AWS cloud, and it's using the HashiCorp/AWS provider. And there will always be the instruction to use any provider that you want under the use provider button. So here you will get the code snippet that you need to copy to your project. And after you define this, you can use the configuration that it has provided, right? So that's about the AWS provider. But you can also get similar documentation for any other providers that you want. So you can see that you have providers for Azure, GCP. If you, let's say, for Azure, and you can click on use provider, and this is the required snippet that you need to copy to use the Azure provider. All right, so that is about the providers and all those things. So let's move to the next concept. So the next concept is the resources. So these are actually the actual service that you want to deploy or that you want to provision. And Terraform uses the concept of resource and resource blocks, and these are the real one-to-one mapping between your Terraform code and the actual AWS infrastructure. So let's say you want to deploy a VM. A VM in AWS is called an instance, right? And so, and it's the service is called EC2 instance. So you define AWS instance in Terraform. That is how it's written in Terraform. You can check the documentation of what it's named. And if you write this and if you provide the configuration, that is going to be mapped to EC2 instance in the AWS environment. So that's the actual service that it will deploy. Similarly, if you want to provision some firewall rules, so that is what is AWS security group. So you define the firewall for your environment on an instance in this case. So you can define the AWS security group, and that will create the AWS security group in AWS. So you write this will be created, and you create the security group. All right, so that's about the resource. And now for the resources, so you also get the different arguments that comes with different resource, right? So arguments are the specific configurations that defines the specific service. So let us see for an instance an example. So let's say if I want to deploy an EC2 in AWS, I showed you the GUI version of it, right? So I showed you like how let me go back a few slides. So yeah, this is how you would look like this is the first page, and this is not complete. Like you need to go to the next step, you need to define some networking rules, you need to go to the next step, you need to define the storage rules. So it's a lot of work over here. But on the other hand, if you want to do the same thing in Terraform, what you do is that you connect first with the AWS provider. So you need the AWS provider in your code, and then once you have the provider set up, you create a resource, and that's going to be the AWS instance resource, and you give it a name on this. So this is like any name that you can give. So for me in this case, I have named it as web, but this needs to be matched from the documentation that the provider gets. And here we are using an AMI, so that's nothing but the operating system that the instance will use. And AWS has a lot of predefined operating systems, and this is the ID of the operating system. So it's most likely the Ubuntu based instance, just for an example. And you're defining the instance type. So these are the multiple tiers of the virtual machine that you want to use. So T2.micro is the basic one, the most basic one, which has limited CPU and memory space. So this is like the best tier one. And then you provide it some with the user data. So these are just the initial script that will run when you provision the instance, and you give it some tags. So this is just all that we need to create an instance in AWS. Of course, you can provide it with some additional arguments and additional configuration as per your requirement. But this is how simple it is to create AWS instance using Terraform, right? And we will see how to do this in the demo as well. So yeah, I can also show you a sample. So let's say I want to create AWS instance in Terraform, right? So AWS instance and Terraform. So I'm just going to search for that, and you can see that we have a resource documentation right up here, and it will give you the example on how you can actually use the AWS. So you can see like this is the resource that we need to use. So this is like a resource block, and this will create the AWS instance, right? So this is very simple. And here you can see that it is getting the AMI ID, which is like the name of the operating system. It's not hard coded, and it's being fetched from a data block. We will learn about the data block in a second. But yeah, everything it's first fetching the latest AMI for Ubuntu, and then it is populating that under the AMI field in the resource block. But this is actually what is creating the AWS EC2 instance, right? And you can see that it provides the EC2 instance resources, and you can see for all the services that you can think of in AWS, you have the resource. For example, if I want to create a VPC, right? So I'll just search for VPC, and under the AWS VPC, here you can see that under the virtual private cloud section, we have every option. So we have the option to create a default VPC, but if you want a custom VPC, then you can create a custom VPC with the AWS VPC options, and you can see our basic uses. So with this just 3 lines of code, you can create an AWS VPC. That's easy. All right, so let me go back to the slides. That was about the sample resource, and these are what we call as arguments. So this was the resource, and AMI, instance type, user data. So whatever you write inside these are the different arguments that the resource supports. All right, so next up we have variables. So this is to make your Terraform code even more reusable. So let's say you want to deploy a lot of S3 buckets, right? So S3 buckets is nothing but like file storage service that you have in AWS cloud. So if you want to store a lot of files, static files in your AWS environment, then that's most likely when you will use the S3 buckets. But if you want to have like create hundreds of S3 buckets with different names, then you can put those names in a list, right? And just run a loop for all the resources. And that is what you can do with variables. You can create a variable block, and you can use that code again and again. So it's used for like reusable code, and it also makes your code more modular. It's similar to function arguments that you use in programming. All right, so for example, if I say that if I want to if the AWS region, which is actually the data center where my resources will be provisioned, so let's say if it's changing, right? So right now it might be I want to deploy a service in US East 1 within North Virginia, and next time I want to deploy it in US West 2. If you are living in EU, then you can use the EU data zones, right? So rather than hard coding this value, so I don't want to hard code the regions value in my Terraform code, and because and I want to be able to switch it very easily whenever I want, then I can use the variable concept. And here you can see that I have defined AWS region as my variable. So you can write any description that you want. You can define the type for the variable. So in this case, it's just a simple string, and you define the default value. So if you don't provide any value by default, so it will use the value from here. So that is how you can set up a variable, and you can easily reference it in your code. Similarly, we also have like outputs, and these are the important information which will be provided by the provider once the resources is created. So let's say you have your EC2 instance created, and now you want to know the IP of the EC2 instance, right? So you want to know the private IP or the public IP, or if you have created a VPC, then you might want to know the VPC ID, those things. So whatever, once the resources is created on the cloud side, you provision everything to Terraform. The resources is already created in the cloud, and you now want to get the value of that provisioned resources, then you can use the output blocks. And here you can see that we are getting the output from the AWS instance, and we are trying to get the private IP of the server that we have just deployed, and you just give it a name that you want. So it's in this kind of, I have named it as instance IP address, and the value is going to be the AWS instance, which was the resources that we provisioned earlier. So remember, like, this is the resources that we provisioned. So this has to be a masked AWS instance, and this is going to be the name of the instance that we have given, right? So AWS instance, and then instead of .server, if you want to use the earlier example, you have to use .web here, and then .private IP. And you will be able to see all the output that the resources supports from the documentation again. So for example, if you provision the AWS VPC resources, and you want to see like what are the arguments that it supports, right? So if you first see, like, these are the different arguments that you can write inside the code, like things like so whatever you can write inside here within the resource block. So these are the arguments that I talked previously. Like, you can define, let's say, the DNS support, the DNS hostname, and for the outputs, the output value, you can only get the output of the things that is under the attribute instance. So these two are different concepts. So arguments is what you can use to configure the resource. So for example, cider block, instant tenancy, and you have like a lot of others as well, like IPM cider block, the pool ID, the DNS support. So these are the arguments. But if you want to, once it is provisioned on the cloud side and you want to get the output, then you can only get the output which are specified here. So you can get the ID, you can get the ARN, you can get the value whether the DNS support is enabled or not, and all those things which are under the attributes. So attributes are for the outputs, while arguments are for the configuration stuff. I hope that is clear. All right. And we also have the concept of local. Trust me, like, this is not a lot, and now we are quickly going, like, after a few slides we are going to go to the demo, and things will be more clear to you. And likewise, we can have like a local block. So these are like a local variables that you temporarily define in the programming code. So you can define local variables. So let's say I want to give some name and the owner, service name and owner for my resources, then I can use the local block, and I can reference this in my Terraform code, so that I can, let's say I want to give a specific label to all my resources, that the developer or the application for which the service was created is X, or the developer is Sagar, which is me. Then I can use that in local, and then I can provide it a value, and I can use them in my tag. Okay, we'll talk about that in the demo more. All right, next up we have the concept of state, and this is really important file for a very like an easy analogy. You can think of it like the .git folder that you have. So in your project, whenever you work with Git, it will create a .git folder, which is like a hidden by default, and everything that you do in Git, right, your all your commits, history, and everything will be tracked inside that .git folder, right? And the tf state file is also similar to that in some extent. because it also keep tracks of the code, the Terraform code changes that you have done, but it more actually compares the last configured state. So whenever you applied Terraform for the last time, whatever was the result on the cloud side, right? Because here you can think of it like a two environment. You have two different environment. One environment is your local environment where you write the Terraform code, and the Terraform code that you write in your PC is the desired state of the infrastructure, versus what is there in the cloud right now in your AWS account or Azure. That's your actual state. And Terraform state file keeps a track of these things. Like it will, whenever you, if you had applied Terraform before, then it will keep the track of the last configured applied state. And wherever next time you make some changes to your, so let's say I first created a EC2 environment with t2.micro, which was the tier, and now I want it to be like t3.large instance. So the definition changed, right? Because earlier it was a t2.micro instance, but now I want a t3.large instance. So Terraform will already have the knowledge that the last configured state had a t2 dot micro instance, and now when I want to apply it, it will notice a difference, and it will only apply the necessary changes. And Terraform will figure out all the intermediate steps. Like you don't have to worry about what additional things you should have configured or in which order certain things should have been defined. So in case you want to create, let's say, a VPC, you need a subnet, you also need internet gateway, you also need the route tables and all those things. But Terraform will identify like in what order you need to create these resources, and everything is tracked inside the state file. So that's a really important file that you need to care of. And it's managed everything by default, so you don't need to edit, or you should not actually edit the JSON. It's a JSON file, but you should not touch this file ever by yourself. You should never touch this file. It's just there by default. Whenever you do something, it automatically keep tracks of thing. And there are actually two ways to keep track of the state file. So the first one is the local one, which is not recommended, by the way, because the state is only in your PC. But if you're working with like several other people in the team, then the state is only tracked in your PC and not with anyone else. So it's really difficult for the other developer to know the current state of the infrastructure in the cloud. So what you actually want to do is you use a remote state. And in this case, the remote state is nothing but just a file on the cloud, and that file is the TF state file, but it will be on the cloud, so that it's, since it's on the cloud, every team member can use that, and everyone will have a real-time status of the current state versus a desired state. So if there are like multiple people working together, and if someone applies some conflicting changes, then the Terraform state file will lock itself, and it will prevent the overlapping of service configuration. So every like the infrastructure will not collapse. So that is why the recommended way to keep your state file in the cloud. And in this case, I'm going to show you both the way of keeping the state file in uh, local, that is just for your PC and development purpose, it's fine. But I'll also show you how you can do that with AWS cloud, and keeping the state file in S3 bucket. So we will have our tf.tf state file in S3 bucket, and that way it's always on the remote. And if I can quickly switch my PC, I can do anything, I can work from any other location or laptop, and I can share that with my teammate, and everyone knows what's the current versus the desired state is. So yeah, so you have the Terraform command line interface, and you have two different ways to manage the state. So first one is the local state file, but you also have like remote options. S3 is just one example. You could also use other cloud service provider, but you can use S3. And in production environment, you don't need to do this right now, but in production environment, you can also prevent the state locking thing with the help of things like key value store database like DynamoDB in AWS. But you don't need to worry about this right now. It's just there to prevent let's say two different developers, they are trying to do two different things like at the same time. I want to create a t2.micro instance, but the other developer says that they want to create a t3.large instance. So that's a conflict, right? And how on earth the Terraform will know which instance to create if two people are executing two different commands? So Terraform will lock itself with whenever the first command was executed, and next time if the other person wants to execute that command, it will throw a warning that there is a conflict. So if you actually want to destroy like create a t3.large, then please be sure that you want to, and you have to unlock it, and then only you can provision the infrastructure. So it's a really useful tool, but we don't have to worry about that right now. So yeah, so for the basic commands and everything, and we now get to the demo part of things. All right, so let's get to the demo. Okay, so again, for all the command which I have showed, please follow the notion page that I have given you. And here, if you go to the prerequisite section, so you know that first we need AWS account. So if you already don't have a AWS account, please sign up for the AWS account, and you have a lot of free tier services that you can get. And everything that I do in this session is within the free tier limit, so you won't have any cost. But disclaimer is that please be mindful with this configuration option that you choose. And if you choose whatever I have chosen in this demo, then everything will be in the free tier limit and you don't have to worry about anything. But if you wanna get like really ambitious, and if you try different things, then things might go wrong and you might incur some cost which might exceed your free tier limit. So be careful with what you do, or always check the pricing for the service that you need. And once you are done with everything, always destroy the resources or clean up all the resources that you use. And that is super easy with Terraform, because if you have done it the ClickOps way, like you had to remember what services you have provisioned and you have to delete it one by one manually. But with Terraform, it's just one single command, which I will show you at the end. So please be careful with the resources that you use. And once you're done with your project, please don't forget to delete the resources. So sign up for the AWS account. For the demo, if you can follow along by signing up, that's great. But even if you don't and can't follow along within the time limit that we have for this workshop, every code and everything is on GitHub, and also this Notion page, and even this stream will be recorded and will be up on the MLS YouTube channel. So you can always watch the recording at your own pace and you can follow along at your own time. So that's totally fine. The most important thing that I want you to know is the concepts and how we actually do things. So that will be helpful. The next important thing that you all need to know is the Terraform CLI, and this is really important. You need to have the Terraform CLI installed. So go ahead to the link, and it's really easy. Like if you have Mac OS, also it's easy on Windows if you have Chocolatey installed. So I would recommend you to go with the Choco, like whatever preferred method it's there in the official documentation. So you need to install one extra tool called Chocolatey, which is not super difficult. And then on Linux you can follow that specifically. All right, so you need to have these two things mandatorily. First, an AWS account. Second, and Terraform CLI. And third, which is AWS CLI, which is optional. Like it's for the authentication stuff. You can, if you already have it, that's nice. If you don't, that is also okay. We will be able to proceed without the AWS CLI installed. All right. So once you have like Terraform CLI installed, let me clear this off and I will zoom this for you. Then you can check if the Terraform is actually installed or not using Terraform dash version, right? And if you do this, like you should see something like this, and that confirms that Terraform is installed. For me, it's version 1.9.6, and that's totally fine. That's about the Terraform CLI. Next up, we need the different code for our application. So I have like two different repos for this demo. So I can show you that here. So first we have the Node.js sample app repo. So this is actually a very basic, like a to-do application, and it uses the SQLite database, which is like a file storage database. It's not a server run database. It's really easy to use, and this is the database that this is the application that we are actually going to deploy right on the AWS cloud. And then we have the Terraform infrastructure code. So on the second repo, this is like the full final code that you will write. So this is like a final code that you will see, but we will see how the code is written and what everything is in here one by one. But this is like a final code. So if you always want to check the final code, then this is also in this repo. So talking about the application, so like I said, this is a simple Node.js application. You can see that you have a Node.js application here, and it's running on, I don't know, like port 3000, I believe. Yeah, so it's running on port 3000, and it's using the SQLite database. It also have the option to use the MySQL database, but for that you need the MySQL instance, and I don't recommend that for this session because we want it to be super simple. But you could also potentially use MySQL because we have the configuration for MySQL as well. But just running on SQLite is fine, and everything will run super nicely if you just have the SQLite database. Okay, and then for the infrastructure, so this is actually the architecture of the infrastructure that we want to provision. So first, we will have something called the AWS region, which I already talked. So these are nothing but the data centers in the AWS cloud. So we are going to use the US East data center where we will provision the different resources. So that is one thing that we need. That's the reason. And by default, if you provision any resources in AWS, it's gonna be in some specific region, and you can choose the one which is nearest to your location. But yeah, for if you just want to follow the demo, then you can choose the US East one region. We also need a VPC, which is like a virtual private cloud. It provides the different subnets and the IP address for all the instance that we use and everything that we provision inside the VPC. So it's for the networking stuff that we need. And then we need a subnet. So we divide our VPC into small subgroups, which are called like subnets. And this is going to be like subnets, but we are not going to deploy it in 3 different availability zone. Here you can see that we have like 1, 2, and 3 different availability zone, but it might cost a lot. We can do that. It's just like 2 lines. We just change 2 lines and it will provision like 3 instances of it. But to keep our cost down, we want to keep it in 1, and to stay within the free tier limit, we will just have like 1 subnet and then 1 EC2 instance. So this is going to be your EC2 instance, which is a virtual machine on the cloud, and we are going to use the t2.micro instance. So that is how it looks like. And we also have the internet gateway, and the internet gateway is a AWS service which is required for the instances inside the VPC to access the internet. So since our application need to download the node packages during installation, it needs the internet access, right? Because we are going to download the node packages, and we are going to also use the PM2 server, which is used to actually serve the Node.js application. So for all of this, our instance needs to be connected to the internet, and for the instance to be connected to the internet, it needs the internet gateway. Yeah, so that is how we have the why we have the internet gateway. And there will be a table which will route the traffic from our instance to the internet gateway and vice versa. So that's all that we need. And for the actual AWS resources that we'll provision, so like I said, we'll provision 1 VPC, we'll provision 1 subnet, we will provision 1 internet gateway for the internet access, we'll provision a routing table which routes the traffic. So if there is any like external traffic, or if our instance wants to connect to the internet, then the traffic will be routed to the internet via the internet gateway. So that is why we need a routing table. We also need a security group, because our application will run on port 3000. We need to allow the inbound access or the access to our instance on port 3000. So I think like you all have visited every website, and you see HTTP or HTTPS, right, mostly. So those are also like specific ports. So HTTPS is port 443 by default. You don't type it, but it's there by default. And if it's HTTP, then that's port 80. But our Node.js application is running on port 3000. So we need to open port 3000 on the instance, and only then the end user or the client will be able to access the instance. So that is how it works. So we need the security group, and then we also have the 1x virtual machine, which is going to be the t2.micro EC2 instance. So yeah, this is going to be the architecture of the cloud services that we are going to provision. All right, enough of that. So now let us go to the AWS account and set up all the things that we need on the AWS side first. So we just need to set up, like I said, if you go to the documentation, you can see that we need to set up an AWS user which has access to the administrator access. So we need to create a user in AWS account, and that user need to have the permission to create all the resources. And what we are going to do later on is that we will give these credentials to Terraform, or the command line that where we execute our Terraform command, so that whenever we run the Terraform command, it somehow needs to connect to our AWS account, right? And to connect or to bridge that, we first have the provider, which is like which translates the Terraform code into respective AWS API calls. But again, that's not enough. Like having an AWS provider is not enough. How will it connect to your specific AWS account or your specific AWS environment, right? And for that, you need to provide it with your own AWS credentials, and that is what we are going to do now. So we will create the credentials that we will provide to the Terraform. So once we create these credentials and provide it to the terminal or the Terraform client environment, then we are going to finally be able to write the Terraform code that we need. All right, so let's go ahead and do that. Let me come here. Okay, here it is. So let me quickly refresh this. All right, so I'm in the Terraform console. So once you sign up to your AWS account, this is the first place that you will see. Like once you log into your dashboard, which is going to be console.aws.console. You can also always search for AWS console, and the first link that's going to appear, so that will take you to this page once you log in. Once you log in, you need to search for IAM service. So that is like the identity and access management, where we will create the user that the Terraform will use, right? So I already have one user set up, but you can go to access management and under users, right? You need to create over here. Then we'll click on create user. All right, and you can name it anything. You can give it your own name or your developer's name or whatever you want, but I'm going to give it like Terraform as a username. So that is going to be like the user which we will create. And since everything is going to be through the command line interface, right, we don't need access to the console, since that is what we want to avoid. So for this specific user, by the way, I'm logging as a root user or an administrator user in this case. So I do have access to all the AWS consoles as well, because once you provision the resource, you do want to come back to the console and see if everything is right, and you want to get a quick overview. But for the Terraform code that we write, for it to authenticate with our AWS, it does not need to have like AWS console access. So we can just uncheck this. We don't need to provide it the because everything is going to be through code. So no console is needed for the Terraform user, not for the, because remember, I am a different user and that this is a new user. So I don't want to add it to any group. I don't want to create a group right now. By the way, you can create a group and assign rules to the group and then permission to the group, and every user within that group can access it in the same way. But I'm going to attach policies directly, and we need to, as I said, I need to give it the administrator access policies. So source for like administrator access, and yeah, I will click on like this one, and then once this is done, I'm going to click on create next administrator access, and then done. By the way, like if you are a bit more advanced cloud user, then you can restrict the permission. You don't need administrator access for everything, but for the sake of simplicity and to avoid like permission issues during the demo, you can choose the administrator access, because administrator will have access to almost anything that you want to do in AWS. Yeah, that is going to be done. And then let me do give it a tag. So this is just a label that it's created for Terraform. You can leave it as well, you don't need to. Okay, once the user is created, um okay, we do have like the user created over here. And now what we want to do is that we're going to check if it has the right permission, and yes, it does have the administrator access permission policy. You can see that it allows any action on every resource. So this is like a AWS way of defining the permission. You don't need to worry about that. But the thing that we are interested is called the security credentials. Yeah, so you need to go to the security credentials tab, and from there we will now create an access key that we need to provide it to Terraform. All right, so let me click on create the access key, and for here you can select the CLI access. But since Terraform is like a third party, and since I will not be using the AWS CLI commands, like I don't want to directly use the AWS CLI command. By the way, you might want to use the AWS CLI commands as well. In that case, you can choose this. But just if you're using Terraform, then you can choose third party service, because Terraform is third party and it will manage the infrastructure on our behalf, right? We are not going to provision anything manually on the cloud. We are not going to click on S3 and do it manually. We are going to use the cloud Terraform. So it's a third party. So yeah, I confirm everything is okay, and then I'll click on next, and I'll click on create access key, and now I get the access key and the secret access key. So you can see that I have the access keys and everything over here. So what I'm going to do, by the way, I'm going to delete this user after the stream. So this is super important that you never share that access key or the secret access key with anyone. This should not be in your GitHub repository. This should not be in your any central thing where you are sharing with other users. This is not for that. This is just going to be in your local development environment, and only for you, only for your access. So yeah, so how now next thing that I'm going to do, okay, so next up, let's say I open up my give me a moment. Yeah, okay, I open up a terminal, right? So I'm in my terminal. So now since I have my AWS access done, so I'm gonna use so from the path where you want to write the Terraform code. By the way, I would highly recommend you to like either clone the repo that I have provided. So you can see that there were two repo in the GitHub that I shown you earlier, right? So first was the infra repo, and the second one was the application repo, right? So I recommend you to clone this, both of this, so that it's easy for you to follow along. And from the terminal where you want to write the Terraform, you need to export different things. So I will open the terminal in the specific folder. So since I am already inside that folder, it's fine for me. But if you are not inside the path where this Terraform code is written, then you need to first cd into that path, go to the folder or the path where you have cloned this Terraform folder, or where you are going to write the Terraform files, and in that terminal session you need to export three different things, and that I have provided it in the guide that I provided. Just give me a moment. Let me bring this guide in this side. All right. So it's gonna be in this specific format. So I'm just gonna copy this one by one. So first the AWS access key, right? So AWS export. You need to use the export command, and this will export the credentials to this local session. So if you do it outside the folder where the Terraform is located, it's not gonna be valid, and Terraform will not have the access to your credentials. So if you want to do it for like one time and forget about it, then I recommend you install the AWS CLI. And if you have the AWS CLI, instead of doing this export thing, you can just use the AWS configure option. So this is like another tool, but you don't have to do this. Just this is like another way which I want to show you all. AWS configure, and you can here provide the AWS access key which I have just shown you, right? From the AWS, you can copy the access key, and likewise you can copy the secret access key, and then the reason which you can do like US East 1, right? And then it's gonna work regardless of where you type the Terraform commands. Then that's gonna work, the credentials. But here I don't want to have the AWS CLI installed, so I'm gonna use the like the manual way of doing like exporting the credentials. So first it was the access key. Okay, I'm copied the access key, and under the quotation mark I'm going to copy this. So okay, the access key is done. Next up, we need to do the secret key. So I'm going to copy this format. I'm going to paste it here. And within the quotation marks, I'm going to copy the secret access key. All right. And I'm going to copy this one and right here. Okay. Okay. Now the access key is also exported. And the final thing that I want to configure is the AWS region, which is going to be US East 1. So I'm going to copy all of this. All right. So once the three different things is done, right? So if all of this is done, okay, so once all of this is done, then I can check if my current terminal is able to connect with AWS. And for that, I can do like everything should be working fine, but I have like AWS already CLI installed on my machine. So I can try to do something like AWS S3 LS. So this is a command which list all the S3 buckets that I have in my account. So if this works, that means that the credentials were set up. Yeah, again, you can see that I have all the bucket names over here, right? So this means that this is working. But if you are not using the AWS CLI, then you can check that when we run the Terraform apply or Terraform plan command. So which we will do in just a second. So these are the prerequisites that you need to do. You don't need to do this step. This is like optional, just for confirmation of that our CLI is able to authenticate with the Terraform. Okay, so now that is done. So now we are finally ready to write our Terraform code. Okay, so before that, like if you have any questions, then let me know all your questions, because like I know this is a lot, and this is a lot of things might be super new for you. So I am happy to take on your questions, and once I take on these questions, we will see how you actually write the Terraform code for this, and how it actually provisions all the stuff. Okay, so any questions that we have until now? I would absolutely love to answer them. In the meantime, like yeah, please put in your questions in the chat box, and I will just quickly bring my charger back and be here in like 1 minute. Just give me a break for a moment. Yeah, in the meantime, like please give me all your questions. All right, hi everyone, I am back, and I don't see any questions. Okay, yes, had one question. So it monitors the application, right? The answer is no. I'd say Terraform is actually used to provision the necessary resources that we need with the provider that we use. So in this case, it's a cloud service provider. So it's used to provision the cloud service resources. But it's not just for cloud. You can also provision like different things like Kubernetes, stateless applications, stateful applications, all those things, Kubernetes networking things. You can even set up Docker containers in Kubernetes with Terraform. It's used to create the initial infrastructure that you need to deploy your applications, and you can also use it to create like different monitoring service. Like you can create let's say AWS CloudWatch, which is a monitoring service in AWS, but that's it. You just create the AWS CloudWatch. You for configuring that you can do it to some extent, but other than that you might want to use the other configuration tool. It does not monitor the application by itself. I hope that makes it clear. Okay, so let us go back to the Terraform, and now let us see everything in Absinthe. Okay, so first, don't be overwhelmed with all the things that we have here. So the first thing that we need is the Node.js application. So we saw all that, right? So this is a very simple Node.js application. It also has like Docker file if you want to use it in Docker way, but you don't need to use Docker. We have a simple to-do application. I might want to show you how it looks like. So yeah, give me a moment. I will show you how it looks like. Cd Node.js application. I guess I have the packages already installed, but if not, I can do npm install. Yeah, and I can do npm run dev, and you can see that the database is already, the application is running on port 3000. So I'm going to do localhost port 3000, and yeah, this is how the application looks like. You can create a new to-do tag like buy groceries, right? So yeah, read a book, and I can delete it if I want. I can do like mark cross check. This is the application that we have. We are not focusing on the application side. We are mostly focusing on how we can actually create the resources in order to deploy this application, right? So that is the application, by the way. Okay, so that is the code for the application. I'm going to stop the server right now. Okay, so application is done. The first thing that we need, like I said, remember the concepts that we had. The first thing that we need is the provider. And here you can see that on the provider.tf file, right? Provider.tf file, we have defined the provider. And you might wonder, how do I get this, right? So you can see that it's very similar to the code which is on the official documentation. So let me open up the documentation first. And here you can see that if I go to the AWS provider, and if I click on use provider, here you get the template that you can copy. So it needs a Terraform block, and under the Terraform block, you need to give a required providers block, and inside that there is the list of provider that you want to use. So in this case, I just have like one provider, which is AWS. But if you have like multiples of them, then you need to add all of them inside the required provider block, right? So that is how you are going to do that. So let's see this. So first, you can see that you have the Terraform block as well, just the way we have in the documentation. And under the required providers block, you define AWS. And you can see that the source is also copied from here. You can see that the source is HashiCorp AWS, and the version is 5.70.0, which is the latest one. Which you can change, like I'm using the 4.16 version, but you can also use the other versions that you want. And here you can see like you have two different kind of versions. So first is like the Terraform. This is the Terraform version that you are using, and this is the AWS provider version. So these are like two different things. So they have like two different versions. And here you can see that this project, Terraform project, will use any it supports any Terraform which is greater than or equal to 1.2.0, right? So it needs the Terraform which is greater than or equal to this version. So for example, if I do Terraform dash version in my CLI, you can see that my Terraform version is 1.9.6, right? Which is obviously higher than which falls under this category. So it's fine. But if you have like, let's say 1.1, then this might not work. Similarly for AWS, you don't have like greater than or equal to, you have this tilde sign. This means that the major version can not change, but the minor version can change. So this means that it supports any version with let's say 4.2, 4.3 up to 4.99, but it can't be 5, and it also can't be 3, because this is the major version, the first one. and it can't be changed. If you use the tilde sign, that means that the major version is pinned and you cannot change it. And this is usually to avoid any breaking changes, because with every major uh, version change with the provider, things starts to change a lot and things might break if you don't write this. So it's always recommended to specify the version of the provider that you are using. So we have specified the provider, right? And for now, let us forget about the backend. I don't want to use a remote. This is like the configuration for the remote backend, by the way. But let's, for the simplicity, I'm going to comment it out for now. Imagine that you don't have this right now. And then, so this will create the remote, like the state file, but it will create it locally and not in the cloud. But in the production, like I said, it's recommended to create it in the cloud. And then we have like additional configuration. First, we define the list of required provider, and once we define the list of required provider, we then configure the each individual provider. So this is like the list of required provider, and now this is like just the configuration for the AWS provider. So here you configure the AWS provider, and you can see that if I can click on control click, and it will take me to that provider. You can see that there is a newer version available, but that's fine. And you can see that what are the different options that I can use. You can see that I can define the reason, like the access key, which I could, by the way, I could also define the access key here, but it's not recommended because I don't want to expose my access or a secret key in Terraform code. I just want to it be in my own machine. That's why I just exported in my own local terminal sessions. And you can see all the configuration that we can use in this provider. And here we have just defined the reason, and I have given it some default tags. So this means that any resource that I will create in AWS will always have the tags, will have these tags. And you can see that I have like 3 different tags. So first is like created by TF, which means like if the resources is created by Terraform or not, which is mostly going to be true. And I have defined that using a variable, right? So we talked also about variables. So I can quickly show you that we have like 3 different tags here: environment and application. And I'm not hard coding the value of these tags here in the code itself, and I'm using a variable instead. And that's because if I want to change something, I don't want to change the main Terraform files. I just want to change the variable, and that should change everywhere wherever I have used reference this variable. So in the variable.tf file, you can see that I have a lot of variables. And here you can see that we have defined the variable for reason, which is like the reason you want to deploy. And in this case, the default value is US East 1, right? So if I don't provide anything, then the reason is going to be US East 1, but I have already provided it here, which is like hard coded. By the way, I could have done this using a variable. Yeah. And then we have like created by TF, which is a Boolean. So it's either a true or a false value. And then since it's default by false, so whenever we want to change this, I need to turn this on, right? So, or enable this or make this true. And we have like environment and then applications. We have a lot of other variables that we have used throughout the Terraform code, but I will explain this in a later state. So first of all, I just want you to be very clear with just the provider file. So the provider file we have first the Terraform block, where we define the required version for the Terraform, and then the required version for each of our provider, which you can get from the documentation. And then once we have done this, here our state is local. We will configure the remote state towards the later state stays, and then you can define the variables in the variable.tf file. That is another file that you need to remember. And you can define the type of the variable and the default value. And to set the value, now you have defined the variable, but how do you actually set the value apart from the default value? If I want to, let's say, make the Terraform by TF as true, or I want to provide a specific name to the environment, then how? Because right now it's empty, right, for environment and application. So that is where I use the .tf vars file. So you can see that we have our .tf vars file. In this case, it's dev.tf vars. You can name it anything, but it needs to be .tf vars. So this is like a variable file. So you can define the value of the variable that you want to override, everything that you. So these are all the variables that I have used throughout the project. But in provider, I just have like 3 variables. And you can see that the value is like for created by Terraform, it's true, which is like, since it's a Boolean, I have given it a true or a false value. In this case, it's true, which I'm overwriting, because if you see variable.df, it was false by default. So I'm overwriting it here. And then for the second, we have the variable.environment, which is going to be like a dev environment. You can name it anything. And the application, you can name it anything, but I have given it a node name. Likewise, we also have like 4 other variables that we will use in this project. And the value for this are in here. So I hope this is clear. Like we have the provider, we have the variables, and then we have .tf vars, which is the variables value where you actually override the default values. All right, so that is done. Now remember the back to the architecture that we want to deploy. So remember, like, this was the architecture that we want in the cloud, right? So we want VPC, and then we want a subnet. We also want a AWS instance and the internet gateway, right? So we want all of these. So first, let us see, and let us try to see how you actually um, create all of these. So here I have like minimized everything, and these are all the resources that we will need, right? So here you can see that we have resources for AWS instance, VPC, subnet, everything, and we will go through this one by one now. All right. So first, if you see the diagram, you can see that first we need a VPC, right? And in Terraform, by the way, you don't need to know the order in which the service needs to be created. Like, you don't have to write it in that order. You obviously, it's super helpful if you know the order by yourself. It is in your mind, and then it's really easy for you to write the Terraform code that way, since you need to understand how the things are provisioned in cloud as well. But the order does not matter on how you write. So for example, in my main.tf file, which is like the main Terraform file, it's similar to in Node.js, it's index.js, your root file, right? So we normally name it as main.tf, but by the way, you could name it anything that you want. This is just convention. So first we have a resource for AWS instance, right? And then I have AWS VPC at the second. But the thing is that you need a VPC first. Actually, like in AWS, how it works is that you first need a VPC, and only then you can deploy an instance. Because if you look at the diagram, first there is a VPC, and then there is a subnet, and only there then there is an instance, right? So you need to have these two provisions before you can provision an instance. But in my main.tf, I've written the AWS instance at first, right? So that does not matter. You can change the order. Terraform will have like an internal dependency graph. It will determine the dependency, and it will check which needs to be created first and then second. So it will create the tree by itself, and you don't need to worry. You just need to write the Terraform code that is required. In complex application, sometimes that might not work, and you need to use things like depends on and other things. But that's not for a normal use case. Okay. So now let us actually see how you deploy a VPC. So, okay. So let me go to the Google, and Google is your best friend. So go to Google and search for AWS VPC and Terraform. Right. Yeah. And here you can see that you have the link to the resource block. By the way, there are like two different options to deploy any service in AWS. So one is using the resource block, and the other is using the Terraform modules. So modules are like a more easier way, but it is also like you need to understand the service in a really good sense to use the modules. We will see how the modules looks like towards the later stage. But for all the demo that we are doing today, we are going to use the resource blocks and not the Terraform modules. Okay. Okay, so here you can see that for AWS VPC, this is like a basic uses. If you just want a VPC with a CIDR block, then that is all. So this is like the entire IP range that your virtual private cloud will have, but we don't need like these many addresses. But for the simplicity, you can just copy and paste this. If you want to give it a tag, you can give it like this. It's in the documentation. You can see and all the arguments that it supports, right? So we are going to use some of these. So everything is optional here. So you don't have to provide any specific arguments. Even the CIDR range is optional. So by default, I guess it's always going to be this one. But even if you don't write this, it's always going to be the specific one. But we will have some configuration. So if you expand the one that I have over here, so you can see that first we have defined the CIDR block just like the way we have in documentation, but we do have like two different options enabled. So I want to have the DNS support options enabled and the host name. So if you later on want to configure like have a DNS name for your EC2 instance, which we will use to connect using SSH. We will connect to the instance to check if everything is all right using SSH. And for that, we need the DNS name. So it's even without this, it works. You can connect using the IP, but I recommend using the DNS method. And here you can provide the tags for it. But you notice something different, right? For in here, in the example, the name, there was a tag, single tag called name, and the value was main. It was hard coded. And I also have a tag called name, and I could have like multiple tags. I could have like application tag, and I could provide it like value for something, node app or something. This is totally fine. You can have as many tags as you want, but I don't want to. And here I'm using something new, like I'm using something like evaluation expression, and appending that with dash VPC, right? So this is another concept called local, which we briefly talked during the demo, like the theory session, right? So if you want to quickly populate something, like if you quickly want to populate something with some values that you are using often in your Terraform code, because if you see, like for the next resource, I also can show you quickly, like I'm using the same name, local.name, and just appending that with whatever resource I'm provisioning. So here I'm appending it with dash vpc, so that whenever I see the resource in AWS in the console, I know that it what it was and what it is and how it was created using the tags. So I'm using something called local, and I'm defining that in locals.tf file. And here you can see that we have a locals block, and here I have the name. So I have given it the name of node demo app, and I have also defined the VPC cider in the locals section itself. So what this will do is that whenever I use dollar sign and then with curly braces local.name, it will take the value from here and it will populate it here. So actually the tag value is going to be name equals to node demo app dash vpc. So that's going to be the actual value. So it's just like a temporary placeholder, but since I'm using it again and again, instead of typing it like multiple times, I'm just storing that in locals. That's really useful. Okay, so that is about the locals thing. So this is about the vpc. So we have seen vpc, but if you see the diagram, right, vpc is not enough. We also need a subnet, because you can't deploy instance directly on a vpc, because you need to have it in a specific subnet. So next up, let's look for subnet, right? So here, by the way, like this is the from the documentation, so this has to match the documentation. So if you go to AWS vpc, you can see that this is exactly the way it is defined in AWS Terraform documentation, and this is the name that you can change. So this is like a nickname that you give to your VPC, and for me, it's like AWS Dev App VPC. So this is the name that you can change, like a nickname, and you can reference this resource using this name, and this is the actual name that it needs to match to the documentations. All right, so that is about the AWS VPC, which is done. For now, our VPC is done. We have configured this. All right. Uh, and then next up, we have like AWS subnet, right? So here you can see that for the subnet, again, I can go to the AWS documentation, and since I'm already inside AWS, I can just search for subnet over here. And inside VPC, I should be able to see the subnet. Yeah, here under the resources, not the data sources. I want to have it on the resources. You can see a sample uses, right? So for the subnet, you define the VPC ID and the CIDR block. So those two are the most important thing. The VPC ID of which the subnet should be part of, and the CIDR block of the subnet. So what I'm doing is that first, let us check the VPC. So since I'm creating the VPC already here, right? So this resource block will create a VPC. So I can get the ID of the VPC in this way. So I don't need to wait for the VPC to be provisioned and then see the outputs and then hard code it here. I can just use like AWS VPC. So this is like referencing to this resource block. And then I need to provide the name that I've used. So dot and then the name of the resource. And finally the ID, since this is a VPC ID. So that is how it used. By the way, I also recommend you to install the Terraform extension, because that will help you to auto complete a lot of things, and especially if you like have like the one which is from the official provider like the HashiCorp. So this is really helpful and will help you auto complete a lot of things. So let's say if this was not the case, like I didn't know what was this, so either there was two way how I could know, like you can see that the one way is that since I need the ID of the VPC, right? So I could go to first the VPC, and under the attribute reference, you can see, yeah, so under the attributes, it's the ID that will give me the ID of the VPC, right? So I can just use dot ID. But also in the example for the subnet, we have like AWS VPC, and this is the name of the VPC dot ID. So dot ID is fine. You can check it from the attributes reference. So I'm going back to the the Terraform code, and I'm going to use the resource, which is going to be like aws.vpc, and then I'm going to use the name, which is going to be dev vpc, and you can see the IntelliSense is automatically suggesting me to use the ID, right? So that's the benefit of using IntelliSense. It will help you to identify what the ID is. Okay, so next up we need to define the CIDR block, right? So this is going to be the actually the subnet range for your specific subnet. You could have like multiple subnet and you could divide it different CIDR range, but I'm here using a Terraform function. So this is like a new concept in Terraform, which will automatically calculate me the CIDR block from the VPC CIDR block that I give. So in the example, in the demo, like you can see that it has hard coded, right? So this is going to be the CIDR block for one subnet. For another one, I could use like 10.0.2.0/24. And for the next one, I could use like 10.0.3. 0/24, right? So maybe the subnet range will change, but that is how I could do it in a hard coded way. But the better way is to use like Terraform. I can show you that Terraform functions, and these functions will help you to do achieve some of the tasks. So it can have a lot of it has a lot of benefits, like to identify a maximum value among three. It has a lot of other functions as well. You have like functions for date and time, you have functions for string manipulation, you have functions for a lot of things that you can check in Terraform. And I'm using the IP network functions, and I'm using the cider subnet function, right? So if you see that, you have the function here, and it takes the first it takes the VPC. So this is actually the entire VPC cider block. So this is going to be like AWS VPC dot data VPC, and this is the attributes that the VPC will provide. So it will give the cider block, and this is like the number of bits that I want to allocate for the subnet. And this is going to, I just need like since one subnet. So these are not, if you want like three subnet, you specify three. If you just want one, it's fine. So that's the cider block. And for the VPC ID, I already explained that. And the availability zone, it's going to be like for the availability zone. So like in each region there are like multiple availability zones. So let's say for in AWS US East availability zones for AWS, and then you can see that the list of availability zones over here is mostly going to be like ABC with whatever region you use, right? So you can see that the code is for the region it's US East 1, but for the availability zones it's going to be like US East 1A, 1B, and 1C, right? So that's like, and you can get all the list over here. So it's US East 1A, US East 1B, and 1C. So that is how it works, right? So what I have done here in the Terraform code is that I have taken the value of the region from the variables file. So if you see the var.region, which is in the variable file, and the default value is US East 1, so it will take the value from there. I can override it over here, but I have not. I have used the default value, and then what I'm doing it, I'm using it 1. So this will be like US East 1, and this was like var.regions value and A. So this is going to use the US East 1A availability zone. So that is for the subnet, and again that I have given it the tag same as the way I have given it to the VPC. So this is going to be like the AWS VPC and the AWS subnet, but we are not done. We also need like internet gateway. Yeah, you can see that we need the internet gateway. Again, this is from the Terraform provider that we have seen. So I can go to Terraform and then search for internet gateway, right? Gateway, and you can see that on the resource I get that. And here is how you deploy an internet gateway. You just need to provide it a VPC ID, which we have done with just the VPC ID. And then we also provide it with the route table. So again, I will search for like route table, which is nothing. Basically, it will map the traffic from your instance to the internet gateway. Route table, which one it is? The route table one. Okay, so this one it is. And you can see that we need to provide it with the cider block first, and we need to provide it the gateway ID that we have provided. We have created, right? So first we have given it the VPC ID. So VPC ID, again, it's from the AWS VPC, and then we provide the Deva VPC, the name and the ID, and the route is going to be like the cider block that we want to route to. So this represents so this 0.0 represents all traffic not in the VPC, not in the VPC to the internet. So if there is any communication from instance with other instance or with other AWS services within the VPC, then the traffic will be inside the AWS VPC, right? So it will not go outside. But if, let's say, my application, since it needs node packages, right? You know that it's a node application, so it needs node packages. So it needs to connect to the internet. So we need to have a route. So whenever, this means that any traffic which is not in the VPC by default, it will use this internet gateway ID, and so the traffic will go to the internet through the internet gateway that we have provisioned, that we will provision using this resource block. All right, so remember all the things that we have done till now. So first we created sorry for that. All right, okay, so first we created the VPC, that's fine, and then we created the subnet, that is also fine, because in the image you need see that we need the VPC and then subnet. We also created the internet gateway, right? We did that as well. We also created the internet gateway. We also had the route table association. So we need to have also the, like, Once the route table is created, you need to associate this route table with the internet gateway. So there is like the next resource that you need to do. And by the way, where do you find this resource? You find it on the official AWS provider documentation. So whatever resource you need, just search that and Google that with Terraform. So for example, I need AWS route table association, right? So I'll just Google that AWS route table association and then Terraform. That is all that I'm going to do. And I'm going to get the first link, and this will give me the exact way how I should write it in my Terraform with all the required or optional arguments as well as the attributes. So attributes are the thing that I will get as an output or which I can use in other Terraform blocks. Okay. So I have associated the subnet. So that was the subnet. Where is the subnet? Okay, this is the subnet. AWS subnet dot dev app subnet dot id, and I need to associate it the route table with that. Okay, so that is done. All right, so that is done. Now let us go to the instance, right? So here you can see that we have the code for the instance. So, and this looks a bit complicated. So let's first see how a simple instance looks like in Terraform. So let me go to instance first, and then on the resources for EC2, Elastic Cloud Compute, and I have the AWS instance. Okay, so this is how the simple instance looks like, right? So I just need to provide it with AMI and instance type. So that is all the things that is required. Not even the like tags is also optional, but here it is, the tags is provided. So first we have like the AMI, and in this case, how I have done is that, so I have used like a if and else statement. So first it will check if I have provided it with custom AMI. So if I have some operating system image on my own, then what I could do it, since I have defined it in variable. So if you check for variables.tf file, I need to have like custom AMI. Yeah, you can see that there is a custom AMI option which is blank by default. I could provide it here. Like if I have a custom AMI, then I could provide it like value of the ID, like something like this, right? That is totally fine if you have the AMI by yourself, but it needs to exist on your AWS account. Otherwise, it won't work. But I'm not using that. What I'm doing is that it will check if that's true. Since I don't have, like, it's blank, so it's going to use this one. So what it's going to do is that if there is a custom AMI, it's going to use that. But if it's not, then it's going to use the AMI from the data block. And you can see that we have a data block, and it's going to take the Ubuntu ID from that. So now let us learn about the data concept. So data block is used to fetch different information from the different cloud service providers. So let's say these are not the resources that exist in your Terraform cloud account. So if you really want to get something from, you could do it two different ways. Like you could get information about the resources that you already have in your AWS account using data block. That is also fine. But you could also get like other public information from the different cloud service provider. For in this case, we want the AMI, which is like the Amazon machine image, which is nothing but just ID for the operating system. So I can show you that in console first. So let me go back to the console. So let's say if I ever want to create Terraform a like EC2 instance with the cloud, right? Okay, sorry, the my access to the session is completed, so I need to reload it. Just a second. Yeah, okay, that is fine. So if I ever want to create an EC2 instance in Terraform using ClickOps or the manual way, so I could go to instances, and then I can click on launch instance, right? And then here is the option where I select the different operating system that I want. And you can see that every operating system comes with some image. Like for Amazon Linux, this is like the AMI ID, right? And you have a lot of them. So I can browse more AMIs, and here are a lot of different AMIs. But the one that we are going to use is like the Ubuntu one. So I will search for the Ubuntu operating system. Yeah, and here you can see the different images, and you should always select the free tier ones. So that's fine. All right, and now let us see like how this works. Okay, so what I'm doing here is that say instead of hard coding this, because here it's one value, right? But it changes after some time. So AWS releases like multiple updates to this AMI ID, so it gets updated every time. So if you hard code it once, it might break sometime after some time, or there might be some really bad bug in that operating system, and you might want to update it. But you always want to use the latest one when you provision your infrastructure, right? So instead of hard coding this, I'm using a data block so that I can always get the latest AMI ID for Ubuntu by automatically, like from the AWS themselves. So I kept the most recent tag as true. So that is how it is provided in the official documentation as well. So you can see that it's similar to like, and then I apply some filters, right? So I apply the filter for name and the name for the AMIs. You can see that let's say this one, not that one. Let me check something. Okay, yeah, the name is gonna be like it has to match the value that I have provided in the variable, and you can see that in dev.tf this is the name that it's gonna match. So you can see that it's ubuntu slash images slash something, and then we have a wildcard expression at the end, and this is actually the default ubuntu image. So up until here it's always going to be the same, but after this one the name of the AMI is going to be changed depending on the version. So I have kept it as wildcard. It's a regular expression, so it will match anything. If this is matched, then whatever is after this will also be matched. So the name of the AMI is going to be that one. Let me check that. Okay, just a second. I will actually go from here, AMI catalog. Yeah, and then I'm going to search for the this one. Let me actually search this one. Okay. Okay, I don't see any results, but let me quickly search for image Ubuntu, and then the name for the Ubuntu image. All right, so let me check this one. AWS Marketplace AMI, and then yeah, from the this is going to be from, yeah, so this is like the Jamie one. So this is the EMI, right? So and you can see like the different names for that and everything, product details. You can see that this is like the EMI that we are using. So it's from the Jamie one. And you can also get like the full AMI ID, but what we are going to do, we are just going to use the name and then the AMI owner. So in this case we need to provide it the owner of the AMI ID. So it's canonical since it's produced by the official canonical service. So we need to also provide it with the the ID of the owner. And how do you get the ID? Just a second. Like I should be able to see some more details. I don't know. Like it's not showing me properly, like all the details. Ubuntu. Okay, just give me a moment. As VM is enabled, so that's like virtual machines, and then that's got is the canonical ID. But yeah, you can also get this from the official documentation. So like this is the ID of the canonical which I used, and also the virtualization type needs to be like SVM, which is by default. So I provided that, and the owner was canonical. Okay, we'll come back to the data block in just a moment. So for now, just remember that the data block actually calculates the current latest AMI ID, and then after that you can use that over here. So in the instance, you get the latest AMI ID, and that is populated over here. So you don't have to type it hard coded. It just gets the latest AMI for the canonical, because you have set the owners to the ID of the canonical in the dev.tf parts, which is for the canonical, and the name is going to be this one. So it will always get the latest AMI ID. That is how it works. And then you will define the instance type, and also you need to you can to connect with the instance if you want to. You don't have to, but if you want to connect with the instance, you can provide it with the key name. And you can see that it's also coming from the another resource, so AWS key pair. So if I click on this, you can see that we have another resource at the end, AWS key pair, and the name is node app key. And I have actually put on the location of the public key where which is used to connect to this instance. So if I go to the dev.tf files, you can see that there is a public key which I have created, and this key is used to connect to the AWS instance. So that I will also show you how to do just in a moment. So if you have not create, like if you want to create a key that you want to connect to the instance, if you want to SSH into the instance later on, then just go to the Notion page that I have provided, right? And there is a command for you to create a new key. So open up your terminal, just a second. Okay, so go open up your terminal and navigate to the .sss folder inside your home directory. So you have like different keys, and here you can paste this command, and you can give it name, right? This is going to be like ID Terraform, right? So this is going to be like a Terraform ID for AWS. and then I'm going to leave the password as blank. And now you can see that there is like two different files created. So this is a private key without the .pub, and there is also a public key, and you need to provide the location to the public key in the Terraform file. So if you go to the Terraform file, here you need to provide the location. And for me, like since I already created another one, so that was like node id and then underscore rsa.plop. So this is the location of the public key. That is done, right? And so that is about the public key pair, which is used to connect to the SSH instance. And then we also enable the public IP address. So if you go to the Terraform documentation and you can go to the arguments, and you can see that we do have associate public IP address option. So this will give it a public IP address so that we can access the instance via the IP. So since we don't have a custom domain right now, we want to access the instance via the IP address. So we will turn this on. So that is done. And then we also need to provide it with like subnet ID. I will talk about security group in just a moment. And then we need to provide it the subnet ID, since we have already created subnet. You remember that, like we defined the subnet over here, so we can provide this value. So yeah, the subnet ID. And then also we provide like block size of 60 gigabytes. So that's like the volume for the EC2 instance. And then we don't need that much, but that. And I also provide it with the tags. And again, I'm using the local block. So that is about the local blocks. And also now the thing is about like two things are remaining here: the security groups and the user data. And security groups is nothing but like I have defined two security groups. You can see that it is a list and not a string. So first is we have provide in a block square, we have two different values, and we have populated the values. So these are like two different strings, but we have populated that using the AWS security groups resource. If I go to the resource, I have like two different security group resources as well. So if I expand this and expand this, okay, so we have like two different security group resource. And again, I can show you the security group documentation as well. So if I go to the security group, and here you can see that this is how you actually define security groups, which is nothing but a firewall for your EC2 instance, right? So this is like a security group for your EC2 instances. So how you do is that you create a AWS security group resource, and then you can give it a name. So let's say for if you want to allow access assets, you give it a name. Then you need to define the VPC where the resources will be. And then you have two different blocks, like the ingress block and the egress block. So ingress is like the inbound access that you want to allow. So right now I want to allow access from anywhere. So 0.0.0/0 means anyone anywhere in the world can connect to my instance, but they need to have the credentials that has private key that is used to, like public key and private key pair, that is used to provision the EC2 instance. And since I have defined the port as 22, so that's the port for SSH, and the protocol is TCP. So this will create the necessary security group rules and firewall to allow SSH access. We need to open port 22 on the EC2 instance. And similarly, like egress is 0 and -1 from port 0, and protocol is -1. This means that the EC2 instance can connect to anywhere, like the outbound internet access is allowed. So egress only, like port 22 is only allowed for the inbound access, whereas for outbound access anywhere. So since I already said our EC2 instance needs to have access to the different internet services like node modules and everything for installing packages and for installing PM2s and all those things. So that is why we need the egress access. Likewise, since I told you that the application runs on port 3000, we also need to open that. So I will define another security group called STTP. By the way, you could change the name. And we need to again provide the VPC. I have also, like for the demo purpose, I've also opened port 80, but you don't need to, since there is no service running on port 80. But if you just had like a single application or a site which you just want to run by default without appending any port, then you can open port 80 and make sure that the application is also running on port 80. So that is fine. But for our case, this is more important. We again allow ingress from anywhere. So any user should be able to connect to my instance using the IP. And if they go to port 3000, then that should be allowed. So again, this is using the TCP protocol. And again, for egress, any outbound access is also allowed. So that is about the security groups. So let me go back to the instance. So that is security groups covered. And finally, we have the user data. right? So these are the data which is like base 64 included. Again, this is like Terraform functions, so function inside another function. So everything is base 64 included, and I have provided it with the file, and that file is going to be path.module. It will look for the provision.script variable like inside the current directory where the Terraform main.tf is located. So if you go to the var.provision stuff script, let me quickly show you that variable and then provision script. There is a variable for that, and if the dev.tfr, you can see that the script file is actually located inside the scripts folder, right? So it is the user underscore data.ss, and here you can see that this is nothing. You don't need to understand this. This is nothing but all the instructions that you need to start the Node.js application inside the server. So that is what you need to know. And by the way, like if you have any questions up until now, I would be more than happy to answer. And this is the script that will basically like update the Linux packages. It will install the Node.js server. Like it will install Node.js 18, and then it will also install Git, and it will copy the source code for our application, and it will copy inside the home/ec2 user/app, and then it will install the Node.js dependency just the way we would do in our own machine. And to serve it, like to start Node.js in development server, we just use like nodemon and things like that. But in production, we use things like PM2. So I installed like PM2, and then I started the Node.js app using PM2, and then set it up as a background service using systemd, and then everything is saved. So that is all that we need to do here. The focus is here, not here on how the Node.js application runs, but the provision of the necessary services that is needed for the Node.js application to run. So this is not super important, but I hope like that gave you a quick overview. So again, remember like what we did. So just quickly recapping everything that we did. First, we set up a provider. This is to connect our Terraform code with AWS, right? And remember, we also exported all the credentials, right? So we did the export AWS credential thing. So if I can show you that, yeah. So we did the export AWS credential thing. Because we want to access the AWS, and this is done inside the Terraform folder where we are executing the command, right? So that is done. And then and then what we did is that we declared some variables. We had all the locals stuff in here. So these are like the repeatable names and values that I want to reuse again and again. And as looking at architecture, I defined the resources on the way I need it. Like I first need a VPC and then subnet and instance. So I defined all the resources in main.tf using the documentation. I referenced the documentation and gave it all the values. And then I also use the data block just for the AMI ID to get the latest Ubuntu AMI ID, and also for the availability zones. So if you want to get the latest availability zones, you can also use this data block, but this is not used in this project. If you want to use the modules, then it's used there, but not in this case. So that is for the availability zones, and everything is done. Like we have configured everything. So now it's actually the time to go ahead and apply this. And by the way, yeah, for the output, you can see that we have defined two different outputs. So this is going to take the public IP of the instance, and whenever the code is successfully run, like Terraform actually applies everything, it will give us the public IP in the output. Likewise, it will also give it the output in the VPC. So again, these outputs, so everything that is there in the attributes reference of the resource, you can put it in the outputs tab. So for example, if I go to instance, right? So AWS instance, okay, AWS, and then instance, just a second. AWS instance, EC2 instance. So whatever is here in the attributes form, yeah, whatever is here, I can get all of that in the outputs tab. So for example, like attributes, what was the one that we are getting out? So it's the public IP, right? So I can search for like public underscore IP, and here, yeah, you can see that under the wait just a second. So yeah, here you can see that we do have the public IP reference over here. So that is for the arguments that we have. So that is about the Terraform code. So let us now actually, it's time to actually apply this and see all of this in action. So the first thing that you need to do is to do Terraform FMT. So this will format your Terraform code, and it will check if everything is okay or not. Like if there is some white space or if there is any alignment issue, just it's like the linting service for your code. So it's for Terraform. So everything is aligned, the white space and everything will be removed. You can see that a bit of everything was changed, so it will remove all of that. And then the next thing that you want to do is Terraform validate. So it will make sure that your Terraform code is valid. If it is not, then it will tell you the error in this section. So Terraform validate is also done. So the next thing that you want to do is Terraform plan. Okay, so you can do the Terraform plan this way, but remember that since we are also passing on the values, like some of the overriding the variables using the .tfvars file. So if you don't pass this using Terraform plan, then these values will not be applied, and it will just use whatever is there in the default value. So whatever is, if it's there in the default, it will use that. But if you require something that is not there in the default, then this will not work. So it's really important to pass on the variables if you are using them. So in our case, since you are using the tf.tfvars file to pass on our variables, we are going to use that. So what I'm going to do is I'm going to use dash dash var file. You have to use dash dash var dash file equals to, and then the name of the variable. So that is what we are going to do, right? And that is all what we need. And I will click on enter. All right, so you can see that the backend initialization is required. Yeah, so this means that you know about the Terraform state, right? I mentioned about it. So Terraform did not find any state right now, so it asked us to initialize our backend, which is going to be a local backend first. So I'm just going to use Terraform init for now, which is going to please always do Terraform init before running any Terraform command. So if this is the first time, then you need to change that. Okay, just a second. Okay, like okay, I think I got the, okay, since I previously used like a S3 backend instead of the local one, and I commented out, it's telling me that there was a backend previously and now it's gone. Hi, how can you do that? Are you really sure you want to change this? It asked me for that, but there should not be any issue for you for the first time if you are not using the backend previously. So I'm just going to use the Terraform reconfigure thing. So yeah, Terraform init and then reconfigure. Okay, there is the error. Just a second. I think it's because it's on the second line. Yeah, dash dash reconfigure, and now like Terraform is successfully reconfigured and initialized. For you, what you need to do is you need to do the Terraform init first. That's it. You don't need to reconfigure. For me, like since I already have a backend or the state file in S3 buckets, which is called as a backend, not the backend that you know in from the development server. So since I already had Terraform initialized, that was the error that I was getting. But you should not get any error when you just run Terraform init. So Terraform init is what you should get in the beginning, right? So again, I'm getting some error. I don't know why is this happening. Okay, Terraform init dash reconfigure. Okay, it should work. Yeah, this is working, and now I can do Terraform plan. But again, remember, don't forget to okay. Okay, but this is because like I had some state saved previously, so I will delete the .terraform file entirely right now. I don't want it right now, so now it should not give me any. So this is also a part of debugging. So yeah, keep if you are getting like multiple errors, then like for the first time you can delete the .terraform file, but from the next time, please do not delete the .terraform folder, because it will also delete your state. So that is super important, and that is why we actually recommend you to use the Terraform remote state, because there you cannot change it and everything is synced. So it's really good. And now I should not have any issues. Okay, Terraform init. Let us wait for this to complete. It will pull up the AWS provider code and everything, and it will set it up. All right, so now that's done, and now I will do Terraform apply. Yeah, so now I'll do Terraform apply, and this should work. And we need to wait for some time. Like it's like here you can see that what are the thing that it will provision. So it compared the current state with the actual state. And the actual state in my AWS cloud, I don't have any resources, so actual state is blind. So I will show you that quickly. It's like I will go to you in my AWS account, and I will go to EC2, right? And here you can see that yeah, you can see that there I don't have like any EC2 instance running at the moment. It's completely blank, right? I don't have any EC2 instance. So if I go back to my code, all right, give me a moment. Yeah, if I go back to my code, it detected a lot of changes, and you don't need to be overwhelmed. It said that the resources will be created, right? And it's gonna everything like the key name and everything will be known, like you whatever you have provided before will be here, and whatever will be known after the output, it's also going to be mentioned here. So you will know your private IP after it's created, known after apply, known after apply, and all the things. So it will create the key pair will be created, you will create a route table. So whatever resources you have defined, and all the dependent resources as well. So not just the resources that you have defined, also the resources that these resources might need. So everything will be created, and you can see that it has plan to create 9 different resources. So if you're okay with the plan, just click on yes, and then it will apply those resources. So Terraform apply, Terraform plan, and then Terraform apply is the command. And now the creation process has started, so it will create everything. So you can see the order it is creating, right? So first the key pair was created, and the VPC was created, and then the internet gateway and everything. Okay. Okay, we do have some error importing a duplicate. The key pair already exists. Okay. Okay, so the key pair already exists on my Terraform account, so I might have to change the name for the key pair. So know that key pair new. Okay, I'm just gonna change the name for this one. Yeah. Okay, so that is done. So let me apply this again. So okay. Hey. Wait. Oh, I have some errors elsewhere as well. On line number 51, it says, let's check. Okay, AWS. Okay, so that's not AWS VPC dot v. It's actually AWS underscore VPC. So again, I will do like Terraform plan with var file. Okay, there it's some mistake over here. Okay, the name, since I changed the name to dash new, so I need to change that. So I'll go to line number 22 over here. Yeah, so that's gonna be node add keep here dash new. Yeah, that's the one. And now I will do plan, so everything should work. Yeah, read is completed. Yeah, so now it's like only 2 things will be changed. So I'm going to do Terraform apply. Yeah, that is how I will apply. And by the way, if you don't want to type yes and yes again and again, you can use the auto approve, but I don't recommend that. I want you to see the changes that it might plan and then accept that. So I'm going to click on yes. So the instance is on the words of creation. All right, so let's see this, and after this, like, we should be done, and our instance should already be up and running. So it's kind of, yeah, you can see that everything is created, and I even get the public IP of the instance as well as the VPC ID. So this is actually the IP address of the EC2 instance, and since I got this because I mentioned this in the output, so what is the output, I got them over here. And there are like other ways to get the outputs as well. So if you go to the resources that I provided, so there are the other Terraform commands, like if I can just type Terraform output, right? Terraform output, and then I will get the list of all the outputs again. If I want to see all the providers that I have used, then Terraform providers, then this will give me the list of providers. So in this case, it's just one, which is the AWS provider that's I have used. So all the commands that we have used. And also, if you want to see the current state of infrastructure, then you can type in the Terraform show command, and it will give you all this current status. So let us now go back to the console and see if everything is okay. Okay, so now we have the instance. And remember, this is the beauty of Terraform. We did not do anything on the cloud manually. Everything was created by Terraform on our behalf. And for the first time when you are learning this might take time, this might be confusing, and it's totally fine. But you will love Terraform the more you do it. Like from the next time when you want to create like other instances, it's super easy to just reuse the code from your previous ones and just change say different values, and your new instance is already created. So that is how you do it, and your instance is running. You can see the public IP. Also, I want to show you like the VPC that we created. So we needed a VPC, right? So here should be like, we should see a VPC as well in the cloud. So if I go to VPC, and here you can see that there was a new VPC which was created. Yeah, and then like we have 3 different ones, and I'm not sure which is this one. If you go to the networking tab, then here you will be able to see the VPC. Yeah, so this is the VPC which was created, 071099. So it's gonna be this one, and you can see the different CIDR range that we have created, the subnet that we earlier created, and the route table association, right? to the internet gateway that we created. So everything that we defined in the Terraform is here. And also you can say the security group, the inbound rule, yeah, we allowed it on port 22 for SSH, and also for port 3000 to connect it to the application. So let us see if the application is already running. So I can copy the public IP, and then or click on like open address. So this have a public IP. So like everything, my app is listening on 3000, since the node app runs on 3000. So I should not be able to access it on port 80, but on 3000 I should be. So let us check. And not, I'm not able to access on port 3000, which I don't know why. Like there might be some errors which needs to be configured. Okay, so let us try now. Okay, no, it was just taking some time, and now you can see that the application is running toward found. So our application is already on the cloud, and everything is done. So the way it happened is that first our application connected to the Terraform using provider. It provisioned all the resources, and it also like use this user data. User data is nothing but a script that will run for the first time when the instance is loaded, and this script is what actually installed our Node.js application and started it in the VM. So what I can also do is I can copy the I can connect to the instance using connect, and then with the SSS client I can copy the command. And let's go ahead and go to the terminal, right? And from the folder where you have access to the SSS keys, you can just change the key name. Just a second, this was not the key that I have. This is going to be node underscore ID. So this is like the private key that I have. And now you can see that I can SSH into the instance. Give me a second. Yeah, now I'm in the SSH instance. So if I do like cd/ec2, which is the path where the application is located. So this is going to be, oh, just a second, give me the let me check the command. So this is going to be sorry, it was /home/user/app. So okay, so cd, and here you can see that we have the application code over here, and since it's managed by PM2, you can see that the PM2 process is already running, and everything is running fine. So our code is done, everything works fine. All right, that is done. So we have completed almost everything that we need to cover for this session. The other thing that I want to show you is the concept of like remote state. So since now I am using like local state, since this is commented, but the other better way that you could have done this is to create a bucket in Terraform, in AWS. So I will show you how I have done that actually. So I will open my S3 bucket, and here you can see that I have like a bucket name for Terraform backend personal div. So you can just create a bucket by just giving it a name. It's super simple to create a bucket. You can leave everything as default and then create a bucket. And once you create the bucket, so the name of the bucket for me is Terraform backend personal div. And then the bucket name, what you need to do is you need to add this block of line like backend S3, and then bucket, it's going to be the name of the S3 bucket, the region where the bucket is located, and the encryption, which I have set it to true, and the like folder path where you want it's not actually a folder, just labels of the files, where you want the Terraform state file to be located. So for me, since I want to use this bucket for like multiple projects, right now I only have like one folder, and inside there I have the state, but you could have like multiple projects, and you all use the same bucket. So that is how you do it. So if you want to do it that way, then you can also do that. And if you change the backend and something, you always have to do Terraform init first. So Terraform init, and then you have to do it again. But since I have already done everything, so it will give me a conflict. So yeah, oh sorry, it has been initialized. Okay, nice. Terraform init. But since it will conflict with the resources that I have, so I need to do the Terraform apply again. Yeah, you can see that. Do you want to copy? Yeah, it is asking me to copy from the local that I have, the state that I have, to the new one, and I will of course do yes, because I do want it to match the new one. And now from the next time, even if the .terraform folder is deleted from my local machine, everything will run just fine. So that is the end of this demo, folks. We have successfully provisioned all the resources, everything that we need for deploying our sample Node.js application on AWS cloud, in VPCs, the EC2 instance, the security group, the route tables, the internet gateways, and everything that we need. And that is all done. So I will go back to the slides. And if you have any questions, again, if you have any questions, then please, now is the time to ask. Like, we just have a few minutes left, so I would be more than happy to help you out and answer all your questions. And please, um, check out the resources that I provided and the code that I have shared with it. It has all the GitHub and everything that you need. So you can try this on your own at your own pace. So follow along. If you have any questions, you can also ask me at any point of time on my socials. So I'm always there for you. All right. So thank you, everyone. Before I leave off, here are the important resources that you can use. So officially, check out the AWS provider, the registry, and everything that I've used in this demo. It's over here. Also, there is a specific guide for the MLS community with some video tutorials. So that's also going to be useful. And also check out the Terraform modules, which is like a bit advanced concept, but I have some samples in the repo itself that you can check out. Okay, upcoming, like there is another beautiful, wonderful, super fun Bob Ross MS Paint mini event, and you can join our fellow MLS coaches Claria and then Stefan. So that's going to happen at 8 p.m. EDT. So make sure you register for it. And then this is going to happen on the MLS Discord server. So hop into the event and have a super fun time painting the amazing pictures from Bob Ross and also with Clara and Stefan. So I hope you're going to have a lot of fun at that one. So that's going to happen in like few hours. Make sure you join and check that out. Yeah, we do have some questions. Can we deploy a Monstack project using Terraform? Yeah, the answer is yes and no. You can deploy everything that you need to deploy, like all the service, AWS or cloud services that you need to deploy your Monstack. So let's say you can provision the database, you can provision the EC2 instance, which will have your the Node.js application. You can provision S3 bucket, which can be used to serve your React files, or just the EC2 instance. You can also provision CloudFront. There are like multiple ways to deploy Node.js application in Terraform in AWS, and you can provision the service. But for configuration, you can only do it up to some extent. You cannot configure a super complex application all with Terraform. Like for me, it was a simple Node.js application, so I could do it with like user script, right? So that was easy. But for something more complex, there are dedicated configuration tools like Ansible that you might want to check out. So for the provisioning of resources that you need to deploy a Monstack application, 100% yes, you can do that with Terraform. But for configuring the Mon application itself, then that case, like you might want to check like other tools like Ansible. Okay. I hope that makes it clear, and that's a great question. There is a need to distinguish the extent up to which we use Terraform versus the other tools. Okay, so and I hope that helps. Thanks, Ivam. Thanks for the questions, and thanks everyone once again. Bye bye. Have a great time and happy weekend. Bye bye. Happy everyone. Have a great time.